In general, our received OFDM symbol will have some sort of non-zero frequency offset. And this is due in part because there's no guarantee of any coherence between our transmitting frequency generator and our receiving frequency generator. As a result, this non-zero frequency offset will result in our subcarriers no longer being orthogonal, and as a result, we may not be able to properly recover all the data. And so it's crucial that we somehow, through a training symbol or PLL, discover the frequency offset and correct it, and that's what we're going to do in this sub-VI. Now again, because we have a complex baseband OFDM symbol, we need to perform complex down conversion through the multiplication of a complex exponential. So let's go ahead and begin. We need our OFDM baseband signal that has the frequency offset, and then we're going to perform this multiplication on a point-by-point basis, so we need to figure out how many points are in our signal through the array size function. And then let's go ahead and create our for loop so we can process it one point at a time. And n, of course, is going to be the number of times we run it, so we put that there. And then, as we mentioned, we're going to be performing some sort of complex exponential multiplication, so let's go ahead and set that up now. And then the only thing that remains to be seen is exactly how we're going to be multiplying our by what product we're going to be multiplying by. And we're going to go ahead and let LabVIEW automatically index for us, because again, we do want to perform this on a point-by-point basis. And likewise with the output, we can easily let LabVIEW enable indexing and build our output array for us as well, our corrected signal. So back to the power, we need to determine exactly what exponential we're going to be multiplying it by. And if this is completely new to you, I encourage you to check out some basic DSP theory, but we need the frequency offset, negative I to make it complex, and then 2 pi because we're going to be taking our input in hertz. And then we simply need to divide by the number of samples that we're going to be multiplying by. If you're unfamiliar with this function, it is the compound arithmetic function. It can be found in the numeric menu, and if it doesn't come out with a multiply, you can right click and go to change mode and choose which operation you'd like to perform. Now once that's done, we just need one more multiplier in our product, and that's going to be the current index that we're on. And that's all there is to it. If any of this is confusing, I encourage you to check out the CNX module or email the author.